that you can talk to on the conjunction tonight. Did someone just join? I saw my screen flash. Anyway,
recording.
Oh, okay. I got a couple things I can show real quick here. I don't know whether it'll be a whole lot.
Jeff, you're muted. Jeff, you're muted.
It won't let me press the space bar when I'm presenting to unmute. Okay, can you hear me now?
Yes.
That's weird. I had it, and you can see my screen?
Yes.
Okay, well, again, no big deal. This was tonight. I got off work and grabbed a sandwich and went to the store. And about 4:30, I got over to by the Pleasant Valley High School, the parking lot there, and I set up my little Mac Newt. It's my grab and go, for lack of a better term. And I found the moon and sat there and watched for a conjunction to rear its head. And so I saw the little point of light, pointed at it, jumped in my car and grabbed my cell phone to take a test shot and got this pic. So that's at 34.8 times. And about 2 seconds after that picture, this covered, and it's right in here at that point in time. You can kind of see that it ruined it for the rest of the night, so I didn't get a whole lot done. But anyway, at least I got it there. But not to worry, of course. Last night, this was the conjunction here, Saturn and Jupiter. And that was at 5:30 yesterday afternoon or last night. And tonight it was a little bit better, you can see. And tomorrow night, it's not a whole lot worse. It's still pretty close. So we've got a couple of tomorrow night yet. And then the 23rd, it's a little bit off. So tomorrow night, hopefully we'll get some weather. But for some reason, I thought I heard that we've got snow coming in or something. Was that right, or did I misunderstand that?
I don't think so.
That's right.
It is?
Yes.
Supposedly Wednesday night.
Okay, so we might have tomorrow yet to get something here. So it'd be really cool to do that. But anyway, like I said, I didn't have any luck doing anything. I felt really happy that I was actually able to go out and do something. I didn't have any expectations tonight. I even thought I was just going to pull out the binoculars. Let's see if I can unshare here. Stop sharing. Okay. I'm going to, Rusty, do you have anything that you wanted to show?
Well, I got a couple pictures last night.
Yeah, go ahead and put them up on the screen.
All right, let's see if I can find them here. Well, I gotta search.
Good, Sam, we can go to you next if you've got anything.
I don't have anything.
Okay. And then, Matt, after Rusty, if you've got some stuff you'd like to show, that'd be great. Finding them on your computer is as bad as finding them with the cloud cover, huh, Rusty?
Yeah.
Did you want to go ahead, Matt, while he's looking?
Yeah, go ahead and get somebody else while I get this figured out. What I'm
Okay.
messing up here.
I
can show you mine.
Who said that?
Uh,
Yeah, Al, go for it. Where are you at? Oh, your video disappeared. Now that is one conjunction.
Here's a conjunction for you. That was last night. I used the moon to focus, my camera through the telescope because it was still daytime basically when I did this. What I did is I pointed the scope at the moon and I aligned on the moon, and then I told it to go to Jupiter, and then that's what I got with once I fine-tuned the pointing of the scope because the alignment wasn't all that good.
Yeah.
This was daytime and it was through a little bit of a cloud, so it's not the best, but that was yesterday.
That's pretty much what mine looks like.
Rusty and Terry both were there. We went over to Blackhawk College and set up over there. And I don't know, there was maybe half a dozen people that were curious about what these crazy guys were doing. And so anyway, that was yesterday. And I tried to do something today, but it was, by the time I got the scope set up, it was cloudy. But there was a lot of people over at Blackhawk College today. There was probably 20, 25 people that stopped by and was curious what I was doing and what that bright star was in the southwest before the clouds came in. And
it must have been on the news tonight or something.
Cool. Thanks, Owen. Rusty, did you get yours yet?
Yeah, I found it.
Okay, go for it.
See if I can. I gotta try and find it again. I don't know where it's at. Oh, well. I can't find it in here.
Okay.
I can find it on my desktop, but then when I go to share it, I can't. I'm not sure where it's at.
Okay. Anyway, I'm trying to go as I see people on the screen here so I can keep track. Rolando, did you have anything?
No, nothing for me.
Ron, nothing? Rolando, nothing?
No, I don't have anything.
Okay. Hey, Terry D.
I don't have any pictures. I couldn't long enough to take a picture today.
Yeah, it's been pretty rough. So, hey, Jason, do you have anything? He's still connecting up. Sam, did I miss you?
No?
Did you have anything? Let's see, Jason, Terry. Cecil, I don't suppose you pulled out your big mambo, did you?
Can you,
Yeah.
can you hear?
Yes.
No, I don't. I've been factor, but so I figured out and the any work on need their setup, so a lot faster. But no microphone on.
That's okay. You're making headway, though, at least. A lot better than me. And then there's Jason. What was that, Cecil?
Well, I was saying I conditioned computer to 0.6 gigahertz 16 gram. And
That's to do it.
faster, but the camera and the microphone didn't work.
Welcome, Jason. Did you? What was that?
Said, Top says my camera, I don't see my picture. So that's
Yeah,
yeah, I was last night and I don't very much time here, and I'm gonna have myself tomorrow night. But there's supposed to be snow. I started today.
Yeah. So, Jason, do you have any pictures or anything that you'd like to show or talk about or anything? Oh, you froze.
Here you go.
Yeah, I don't know if we lost Jason or not.
I don't know, I can show you mine real quick.
Yeah, go for it, Matt.
All right, so this was just to show you how bad it was out there. So, like, I'm gonna go through the frames on this. This was, I don't know how long this was. This is probably 1,000, but look at that thing boil. So, like, it was pretty bad. I had pretty much zero chance of getting a good picture out of that. So what I ended up getting, that stacks into this, which then in Registax gets me about here. So that's a lot better than I thought it would be from how terrible that video was. At least I ended up with a circle and a fuzzy Saturn. It's not so bad, right?
Not bad at all.
That's good.
When was that? Yesterday?
That was just tonight.
Oh, wow. That's great then for tonight.
So I was in the wind tonight.
Jason sent me a text and said that he keeps on getting kicked out of WebEx. We'll watch for him to come back. Let me see here.
A little bit. Wasn't too impressive, but it was tonight. So
And then Jim, I know that you've got some stuff, not necessarily the conjunction, but what have you been doing here lately and can show off for us? Beautiful pictures, by the way. Oop, I'm not hearing you. I think you're still muted.
okay, so not much with the conjunction. About 4 days ago, we had about half an hour of clear skies and had a couple neighbors get to see it, but it was like between 5:30 and 5:45, so it still wasn't dark. I think they were too impressed. And I snapped a couple pictures, but they're still in my camera. You might be alluding to a few pictures that I took earlier this month and finally got around to doing a little bit of processing on those. My first experience on the Hubble, using the Hubble palette and getting some colors that look like they're supposed to look. So making a little bit of progress there. I put a few of them on the QCAS Facebook page, and I'll put them on the QCAS web page also.
Are they there for you to be able to pop up now or no?
I don't have them on this computer. So I'll have to see if I can do any moving around for a little bit later on.
Okay, I'm going to see. If I can go onto Facebook and grab them. I never use my computer for Facebook, so I have to figure out how to get there. Okay, I think I'm here. Let me go back and see if I can share my screen now. Let me know if you can see my screen.
Yes.
Okay, was this one of them, Jim?
Yeah, that's one of Soul that I processed a few days ago. And then just a few hours ago, I put one up of the heart.
Let me see which direction I go. Oops, sorry about that. Go back to that.
Well, that's quite all right. That's a 300 millimeter Canon telephoto lens. I have a guide scope hooked up to it with an SI camera, and it also has an SI focuser that's driving the focuser on the.
I see it's blue, and that's pretty cool.
Yeah, and the first shots that I took of the heart, the focus wasn't very good on them, and then a few it was better once I used this. Yeah, so there's the heart in the so-called Hubble palette. So it's shot through hydrogen alpha, 3 and sulfur, and then combined using the AstroPixel processor instructions from our workshop that we had.
Cool.
So that one is just using two filters, oxygen 3 and hydrogen. And then there's one more that's just the hydrogen alpha image through the hydrogen alpha. So you can see you really get a lot of light that comes through the hydrogen alpha filter, I guess, because that's the predominant wavelength of light in some of these objects. Unfortunately, our eyes not visible are not sensitive to that wavelength, so we don't see that wavelength when we look at it with our eye, but camera can pick up the hydrogen alpha light.
And is that being on the Hubble palette? Is that being used as a luminance, or is that being used as a color like red or something?
You actually use that. You assign. I mean, arbitrary, but I mean, what the Hubble Space Telescope has done is to the green channel, sulfur to red, and oxygen 3 to blue. And then when you combine those three images, it looks very green because the hydrogen alpha is so much brighter than the oxygen 3 or than the sulfur. So then what you have to do is go within there and a lot of fiddling around, slowing down the hydrogen alpha channel so that the other colors come out. And, depending on the object you're photographing, it may have, more or less in those other wavelengths. So a bit of sulfur in both the as the soul, but it happens in about the same place as the hydrogen alpha is predominantly, whereas the oxygen light is dimmer, and it happens to be in the center. So that's why you're able to bring some blue out, in the kind of in the center portion of the heart. And not that I really know what I'm doing. That's a little I've been able to figure out. Other noteworthy of that photo is, down in the tip of the heart is the Fish Head Nebula. So Jeff's got his pointer around there. So with a telescope, with 700, 1200 millimeter, the field of view is probably going to be just about the size of the fish head. Whereas, with a 300 millimeter, then I could get all of the heart. The ZWO 1600, which is kind of a modest size. If you're using a 35 millimeter, you would be able to get both the heart as well as the soul in the same field of view. The chip size is bigger on the, especially with a full frame camera.
Cool. Was there any others in here that we had?
I think that put up recently. I haven't even processed the images that I took at the Eastern Iowa Start Party.
Okay, well, I'm going to unshare here. Okay, before we get to Robert, does anybody else have any things that they want to show or talk about? Cool. Robert, did you have anything that you wanted to do for our presentation or anything? Were you going to give it a shot on that Jupiter Saturn one?
Yes, I can do that. Yes.
Excellent.
A minute here.
And let me mute my microphone again.
Okay. Okay, there we go. Everyone see this?
Looks good.
Yes.
Okay, I originally made this for one of our virtual star parties earlier this year from Menke. And I think that was the day that the internet connection failed unexpectedly, so I wasn't able to put this out. At least I think this is the one I was supposed to put out that day. So it was on a night when Jupiter and Saturn were particularly prominent in the southern sky. And I figured that with the conjunction tonight was supposed to be visible, but no. So maybe I'd kind of tweak this for that. So here are the planets in our solar system. Well, 8 major planets and 1 dwarf planet. And now their sizes are all to scale relative to each other, along with the sun. Obviously, the distances are not, but so you can see that Jupiter and Saturn are easily the 2 biggest planets in our solar system. In fact, Saturn's pretty much a close second to Jupiter. And being so large, and of course being easily visible to the unaided eye, they've been known since antiquity. And the names we have for them now come from Roman gods. Jupiter was the king of the Roman gods. Saturn was his father, the god of the god of agriculture, also known as the god of lead, probably because Saturn appeared to move so slowly across the night sky. But these are just the Roman names for them. Other cultures had their own names for these for the planets, or the gods, as people thought they were. So I was able to find a few examples of a few different cultures, Greece, Babylonian Empire, and in Hindu. At least these are the closest I could come to being the actual names for the celestial objects. Well, actually, conjunctions of Jupiter and Saturn occur about once every 20 years because, well, Jupiter takes 12 years to go around the celestial sphere. Saturn takes 29 and a half. So every 20 years, every just under 20 years, they both come to the same celestial longitude, the same right ascension. Of course, most of the time they don't nearly be as close to each other as they do tonight because the orbits are slightly tilted relative to each other, and more often than not, there's like at least a degree or so separating them. But I thought I might introduce a new word here. It might be new for some of you. Syzygy is what we call it anytime 3 or more celestial objects in our solar system are lined up. So, like, every time there's a new or a full moon, that's a syzygy of the sun, the earth, and the moon. So in this case, a syzygy of Earth, Jupiter, and Saturn. I mean, if we weren't on the same line as Jupiter and Saturn, we wouldn't see a conjunction. Every once in a great while, you can actually have 3 conjunctions of Jupiter and Saturn, all within the span of less than a year. This would happen when Jupiter and Saturn are in opposition at the time of a conjunction. So that way, see, every time a planet is in opposition, it undergoes retrograde motion. So under this triple conjunction, you would have the 2 planets appear in conjunction, then they'd spread apart for a little bit, but then they both go into retrograde and come back to their original positions, more or less. And then a few months later, they go back to moving in their normal directions and they conjunct again. Such a triple conjunction happened in 7 BCE, and some people think that may have been the inspiration for the Star of Bethlehem. And in fact, it's been going on the news everywhere that people are calling this the Christmas star, thinking that maybe there's a connection. But the fact is, the triple conjunction in 7 BC, at every time they were in conjunction, they were separated by about an entire degree. So there was no way that anybody would have been able to see them appear to merge together. So the debate about what the Star of Bethlehem was continues. Feel free to jump in if you have any questions.
Well, I can add something right there if I could. So I kind of have a theory on that. These 3 kings or the 3 wise guys were actually astrologers. They were very well aware of the conjunctions happening. The thing is that they knew that it was closer than normal, and it happened to meet some other specifications, such as what constellation it was going to be in and what time of year it is. So I think that the point to them wasn't really that it was one big star that stayed there for months while they traveled the world to get there. It was more of that they knew that they were apart, but they knew that they were coming together. So they got on their camels and rode toward where they figured they were going to intersect. So I think that part of the star actually being a star, if it was this conjunction, may have been that they knew that it was going to be a close conjunction and it fit some other, parameters in their, I don't know, I don't want to call it their folklore, on their faith or whatever their religious aspects were. So that's all I wanted to add.
But the debate still continues because there were other planetary conjunctions around that same time. So, question of exactly which ones the 3 wise, 3 astrologers were focusing on still remains to be
they were Zoroaster priests and into astrology.
Yes.
And when whatever happened, it was in the constellation sign for Israel. That's what supposedly has, set them off to like, there's something going on in Israel. And that's what sent them on their trek.
Yeah, makes
So
sense.
if it was this conjunction or the conjunction of something else, like we'll probably never know until somebody either creates a time machine or gets trapped by a black hole and ends up going back in time. But that's what supposedly has set them on their trek.
Or until somebody pins down Jesus' birth exactly.
Which you can't, I don't think.
No, with what we have so far. But, so, little background, and this is the closest conjunction of Jupiter and Saturn that has occurred within the last 2,000 years. And so 1.9 arc minutes separation, put that in perspective, a full moon is 30 arc seconds wide. So separation like this, they might truly have seen emerge, along with this one in 1226, which is the last time such a close conjunction was actually visible to people, because the 1623 one occurred too close to the sun. So this is the closest angular separation that they will obtain during this conjunction. And then the next time they'll be that close is in 2080. So if anyone wants to mark their calendars for March 15th of that year, go right ahead. Wait for a laugh. And I did this with Stellarium. I'm certainly not the only one who's done this with Stellarium, but this is, at least with this one, I don't have to pay royalties. All right. So on to the planets themselves. So this is how far Jupiter is from the sun and how long it takes to complete one orbit. So it's actually 11.9 years if you want to be a little more precise. And 88,000 miles wide, and it takes just under 10 hours to complete one rotation. Jupiter is not only the biggest planet in the solar system, it also takes the least amount of time to rotate. And we're all familiar with the Great Red Spot. It's definitely been known to be there since 1830, and maybe as far back as the 1660s. It's said that Galileo was able to view it through his telescope, but I haven't been able to find any definite proof of that. And it has varied in size over its history. Right now, it's a little bit bigger than Earth, but there have been times where it's been like up to 3 times as big as Earth, or is it twice as big? So yes, it has grown and shrunk. It's been shrinking for the past several years now. Doesn't necessarily mean it's about to disappear. It's shrunk that small before. And what's this one? I think Voyager 1 took this movie of it. So you can see how it circulates around in Jupiter's atmosphere. And if you look real close, and you can occasionally see shadows of moons crossing Jupiter's face. They would be the big moons of Jupiter, of course. Io, Europa, Ganymede, and Callisto. of which, so here they are to the same size scale. So Europa is the smallest one, Ganymede's the biggest. And each one of Jupiter's 4 giant moons is farther from Jupiter than our moon is from Earth. And yet they all take a lot less time to orbit Jupiter because of Jupiter's much greater mass and therefore much stronger gravity. Look, Io only takes 2 days to orbit Jupiter, and yet it's a little bit farther from Jupiter than our own moon. So I was just thinking the other day, if we set up a colony on Io, then day and night cycle wouldn't be that big a stretch relative to what we experience here on Earth. Yeah, it's important to know all these moons have tidally locked rotation, just like our Earth. So Io's day is only 2 days long also. Not that you'd ever want to set up a human colony on Io on account of it's the most volcanically active body in our entire solar system. All the gravitational interactions from massive Jupiter and the other large moons are constantly twisting and pushing and pulling and bending, folding, spindling, and mutilating Io's core, heating it up to thousands of degrees. And so Io is literally turning itself wrong side out from all that excess heat escaping onto the surface and just constantly recoating the entire surface with fresh lava. Like here's a couple of eruptions going on just as this picture was happening. This lava is very heavy in sulfur, which is why Io has all these brilliant rainbow colors on it. That's all different sulfur compounds. Europa is experiencing the same kind of gravitational tugging that Io is, but not as much of it. Only enough to melt underground water ice on Europa, which is why Europa is probably the best bet in our entire solar system to find liquid water. For all we know, that icy shell that forms Europa's surface may only be several hundred meters thick. Probably more likely several kilometers thick, but still, it's not too big a stretch of imagination to one day send a robot drill to Europa to drill through the ice and send some kind of a robot submarine into that ocean to search for possible signs of primitive life. There's some different concepts for doing this, nothing definite yet. We're probably still quite a ways from having the technology to make this definitely work. Let's see. Moving outward, Ganymede probably has a liquid water ocean under its surface too, but a lot deeper underground than Europa. And frankly, the only evidence we have that Ganymede has a liquid water ocean deep underground is that Ganymede appears to have its own magnetic field, which means there must be some kind of a liquid layer under Ganymede's surface. And given its overall composition, it's much more likely that it's salty liquid water than the molten iron and nickel that forms Earth's magnetic field. And then Jupiter's other giant moon, Callisto, very heavily cratered on its surface, pretty much no gravitational tugging here. It is just a big, cold, geologically dead moon. Those bright spots you see dotting its surface are like spires of ice, as opposed to somewhat very slow eroding here. So yeah, basically Callisto's surface is pretty much mostly ice with maybe some rocky material, rocky dust mixed into it. And there's some evidence for a liquid water ocean deep under its surface as well. Again, very deep underground. In the case of Ganymede and Callisto, it's probably very unlikely that there'd be life existing in these extremely deep oceans. Just too far from the surface. So far, so good. And then our solar system's other giant planet, Saturn. Collectively, actually, as far as astronomers are concerned, Jupiter and Saturn are the only gas giant planets in our solar system. We know a lot of people think of Uranus and Neptune as being those as well, but in fact, Uranus and Neptune have a lot more liquefied icy materials in their composition than hydrogen and helium. So those two are more often called ice giants than gas giants. Saturn is almost twice as far from the sun as Jupiter. It takes more than twice as long to complete one orbit. A little bit smaller than Jupiter. Well, the planet itself is a little bit smaller than Jupiter. As you can see, the ring system is like twice as wide as the planet itself, which, by the way, takes a little bit longer than Jupiter to rotate. Still, not that much longer. You see the bands of clouds in Jupiter and Saturn, they're the result of this really fast rotation. And as for Saturn's rings, every gas giant and ice giant planet in our solar system has rings. Saturn's the only one that has such incredibly prominent rings. Rings prominent enough to be easily seen from Earth. And it's debatable as to exactly how old the rings are. Did they form along with the planet 4.5 billion years ago and been maintained by different processes ever since? Or are they less than 100 million years old? Evidence is leaning now toward the young ring idea on account of we've made close analysis of the ring particles, and they appear to be made of a whole bunch of particles of all different sizes, which is what you'd expect to happen if the rings were formed by the breakup of a large moon that wandered too close to Saturn and got torn apart by the gravitational forces. Rings that form that way never last very long. They eventually disperse. Particles falling into the planet and other particles drifting out into interplanetary space. So enjoy these rings while you can. As wide as they are, they're no more than a few hundred meters wide. Scale-wise, they are thinner than the average sheet of paper, which is why they pretty much completely disappear whenever they appear edge-on relative to Earth. So this was in 1995. The last time they were edge-on was in 2009. And I believe it will be 2025 the next time they'll appear edge-on. So, still got a few more years to enjoy the view before they're edge-on. Now, I would say that Jupiter has 4 large moons and many, many, many tiny moons. Saturn has only 1 large moon, but several what you might call medium-sized moons, many of which are shown in this diagram here, all to scale relative to each other. Of the medium-sized moons, Enceladus is probably the most interesting one, because we have seen ice geysers erupting from its surface, which is almost conclusive evidence that there's a liquid water ocean under the surface. But Titan is the biggest moon of Saturn by a wide margin. In fact, for a while, we thought it was the biggest moon in the entire solar system until more careful measurements meant that Ganymede just edged it out. It takes 16 days to orbit Saturn, tidally locked like most moons in our solar system, which means its day is 16 days long. But it is the only moon in our solar system that has a thick atmosphere. In fact, it's actually more dense than Earth's. And like Earth's atmosphere, its main constituent is nitrogen. unlike Earth's, there's no oxygen in the atmosphere. Instead, the next most common component is methane, which, when it reacts with ultraviolet light from the sun, turns into these complex hydrocarbon haze, which is why for the longest time we weren't able to see the surface of Titan until we sent a probe to it that had infrared cameras on it. And now we can see that there are indeed lakes of liquid methane and ethane, which are fed by methane rain raining down out of the atmosphere. This is a close-up of one of the largest methane lakes or methane seas on Titan. It has a name. I don't remember what it is right now. And it's also the only moon other than our own moon that we've landed probes on. The Huygens lander was dropped there by the Cassini space probe, and it took this rare photos that it did take of the surface. We think it landed in or near the basin of a dried up lake. What we think is that the lakes periodically fill up and then dry out during Titan's wet and dry seasons. Wet during its winter, dry during its summer, kind of like equatorial regions here on Earth. Let's see, anybody here like drones? Because NASA's planning to send a drone to Titan late this decade to arrive in 2036, and it is going to explore the surface, fly around the surface of the lakes, make close-up studies of the moon's chemistry and possible habitability. It has been speculated that there could be primitive life on Titan. If so, then it'll be life totally unlike what we have here on Earth, because instead of liquid water, it would have to use liquid methane as part of its biochemistry. This is all speculative, of course, right now, but who knows? And let's see. I do have one more thing. Going back to going back to conjunctions before I end this. See, what was his name? Patrick Hartigan at Rice University was doing a survey of planetary conjunctions, kind of researching and simulating when they occurred and when they will occur in from the distant past to the remote future. And actually, in part thanks to his research, I was able to provide the dates and the statistics for those other Jupiter-Saturn conjunctions that I provided earlier on in this slideshow. And he did find something interesting, that there are a few times over the period from 10,000 BC to 10,000 AD when Jupiter will actually occult Saturn. Actually pass right in front of the planet, and he simulated those instances with stellarium. So the last time Jupiter occulted Saturn was in 6,857 BC. And then, believe it or not, it's going to happen twice in the year 7541 AD. Although one of them will just be a grazing occultation, but the other one, full-on cover-up. So, if anybody knows how to live 5,600 years, I get to see this. And with that, I'll ask if there are any questions.
Dr. Mitchell?
Yes.
Yeah, on you said Ganymede had a magnetic field or something?
Yes, its own magnetic field.
Yeah, but it's totally locked with Jupiter, right?
Right. Yeah.
So how does it generate a field from its core? It must have a different type of core than like us.
Well, that's why we think that there must be some liquid layer under its core, and most likely it would be salty liquefied ices.
Oh, okay. Okay, thank you.
Okay. And tidally locked means it still rotates. It rotates once per orbit. So, and in all fairness, Ganymede's magnetic field is very weak compared to Earth's, like several orders of magnitude weaker.
Okay, thank you.
You're welcome.
Okay, excellent. Yeah, it's too bad we couldn't present that for public stuff. That was pretty interesting. Maybe we'll get another opportunity here coming up. Yeah, does anybody else have anything that they'd like to add or talk about while we're together? So if not, I guess I did want to say that tonight is my final meeting for the society as president, and starting next month, of course, Dr. Mitchell will be running the show. We do have a board meeting. What is it? The 6th of January, I think.
Let me double check.
About right.
The 6th. The 6th.
So if anybody's interested in attending, you can blast back an email and get the invite. If I recall properly, Dr. Mitchell, you're president and Paul is vice president and Sam is treasurer. And where'd Jason go? There he is. And Jason is secretary and web guru. Is that all? And kind of the publicity type of stuff, advertising or events and that type of thing. Does that sound right?
Sounds right, yes.
Okay, very good. And nobody's got anything else?
Well,
go ahead.
I should say that I want to thank Jeff for 4 years as president of the club. He did a wonderful job. I hope I can do a quarter as well as he's done.
I'm sure you'll do great. Does anybody plan on going out tomorrow night for the conjunction? Well, I plan on going after work again. I left my scope loaded up in my van, and I'll drive to the top of the hill, and depending on snow and clouds and all that, we'll see what happens. I won't be doing any imaging. It's just kind of cool to see that. And I don't get out that often anyway. So something that is that bright that you can see basically from home, it's well worth going out, even if it's just with binoculars. To me, this is kind of like a solar eclipse where you're almost as well off with a naked eye as you are with any type of magnifying device, because again, the cool thing about this, at least this time around, is talking about it being, a return of the Star of Bethlehem, so to speak, being able to see the two kind of line up and turn into one brighter object. Hopefully we'll still get an opportunity for that tomorrow. So I encourage you all to try to go out, between 5 and 6 and take a peek, even if it's no more than sticking your head out the car window. So with that, anybody have anything else? Otherwise, a motion to adjourn, and we'll call it a quick meeting tonight.
So where in Bettendorf are you? Are you on top of a hill somewhere?
So I am below the hill. So where I went was up by Pleasant Valley High School, which is on top of the hill. And there's a parking lot that is right on the bend. So it's kind of in between Pleasant Valley High School and Scott County Community College. They share that, and it's kind of next to the soccer fields. But if you're driving on Belmont and take the entrance to Scott County Community College, you'll see my van backed right up there. I had people from the city of Riverdale who know that I do astronomy stuff drive by and pull off the side on Belmont and yell at me, asking, if it was still visible. And of course, by the time they did that, it wasn't. So at any rate, that worked well tonight. It was a pretty good view. Unfortunately, there you've got some street lights that are on the parking lot. And then, of course, it's the radio tower. So it's just left of the radio towers a little bit. And that's a little bit distracting. But if you use a telescope, that's not a problem. If you use binoculars, it's not a problem. So again, I'll probably get up there about 4:30 tomorrow. I get off work about 4. So I'll probably drive up there and have a sandwich in the car and wait, unless it's absolutely definitely cloud filled and no chance of anything. So like I said, I think there's a lot of places from in town, Davenport and Moline, that you can go.
It's not like you need a dark sky for this.
Yeah, and of course that's nice, but I think it's over by 7 o'clock anyway, so it's not like it gets dark anyway for this event. But again, it's a bright event, and it's cool to see, even like I said, with the naked eye, to see a bright star kind of during the day. And although it's inaccurate for the time of year, it's cool that it is around Christmas time. So. Anyone else? I'm begging. Okay. Is there a motion to adjourn from anybody? So nobody wants to leave either. Oh, Dr. Mitchell, is there a second then?
Second.
Okay. Well, all in favor of adjourning until next year, 2021? Aye.
All right.
Anybody opposed? That's too easy. Okay, thanks much, guys. We'll catch you all later. Bye-bye.
All right.
Bye.
Bye.
Bye-bye.
I like the presentation, Dr. Mitchell. That was really great.
Glad you liked it.
Yeah, did you add stuff to it for the conjunction, or is that actually what you had?
I added stuff for the conjunction, yeah.
Yeah, I figured as much because, like I said, it tied in really well. So, and it's a good one to talk about even next year, because people will be remembering all the stuff on the media this year. I know that next year they're going to be remembering that when we talked about that. And even for each Christmas, I can send you a little bit on the article I wrote and some of the stuff on the star, because, if we do kind of a Christmas type of thing, it's good to bring up, because although this might not have been the conjunction, it is one of the forerunners as far as theories go. So it's always interesting to do that. So
That'd be great. Yeah, thank you.
yeah, well, thank you very much. And if you need anything, I'm still here. Nothing's changed that way. And I guess I'll see you on the 6th unless you need something else. Are you're not going to head back home over the holiday, right?
No, I'm not.
Yeah,
No.
it's good to play it safe. So anyway, if I don't hear from you, have a wonderful Christmas, and
You too,
I'll hear
Jeff.
from you before New Year, but we'll catch you
Yep.
later.
Okay. Yep.
Thanks.
Happy holidays.
Good night.
Good night.